What we're going to be looking at now is universal indicator. Now, unlike litmus indicator, which we used in a previous video, universal indicator can change a range of different hues and colors. And the color it turns tells you how strong the acid or alkali is. So whereas litmus paper simply goes blue for alkali and red for acid, the universal indicator will go through gradual changes in color depending on how strong the acid or alkali is. Neutral is a nice light green shade, but as you add more and more alkaline substances to it, its color slowly changes from dark green to blue through to purples. Acids, when they're very weak, they'll be yellow in universal indicator, and they will slowly go through oranges and reds as the acid becomes stronger. So it's measured on the pH scale. The pH goes from 1 to 14. The further away from 7 you are, the stronger the substance becomes. The closer to 7 you are, the weaker the substance becomes. So a very dangerous alkali might have a pH of 14, while a very dangerous acid has a pH of 1. Here is the universal indicator. As you can see, it is a green shade. Now it looks very dark at the moment, but that's because it's quite concentrated in this bottle. You usually only use a few drops of it, and that will give you this range of colors. So let's start and have a look at how this works. I'm just going to pop 3 drops of universal indicator into each of these boiling tubes, and then it will be used to identify the pH of the different household chemicals. So we're going to start with water. I'm going to see what color the universal indicator turns. By adding a small amount of water into there, we can see that it is a nice lime green color, and that corresponds to pH 7. pH 7 is neutral. Now next, we'll test the soap. So again, I'll undo this and put a small amount of soap into the boiling tube, and we'll see what color the universal indicator turns. Now by looking at that, you've seen it's gone a yellowy shade. This soap is probably pH 6 on our scale. Let's move on to our next chemical. We will test vinegar. Now, if you watched the last video about litmus indicator, you might have a prediction of what color this will turn, but let's find out. When I put vinegar into the test tube, straight away it turns a really bright, reddy orangey color. I'd say this is around maybe a 2 or a 3. We'll pop that in our rack and we'll move on to the next chemical. We're going to try some hydrochloric acid. Now you probably have a very good idea of what color this will turn. Let's pop it in the tube and find out what color hydrochloric acid turns. So straight away, a very deep red color. It's probably a pH 1. Next, let's investigate sodium hydroxide. Again, if you watched our previous video on litmus paper, you'll have a good idea what color this might turn. But let's just pop it into the tube and find out for ourselves. Oh, straight away, a very, very dark purpley color. That's probably a pH 12 on this scale. So that's quite a strong alkali. And finally, we'll move on to lemon juice. Once again, pour a small amount into the tube and we'll see what happens. And as you can see, the lemon juice is quite a light shade of red. That's probably around a 3 or a 4. Now, the beauty of universal indicator is it can warn us how dangerous a chemical is. Even without seeing the labels on our chemicals, looking at these different substances, you can see if it's dangerous or not. For instance, this chemical is that dark purple, probably a pH 12-ish according to our scale. I would not want to get that on my skin. That would probably cause us some harm to my skin. Similarly, this chemical here is a very dark red, probably a pH 1. Again, I wouldn't want to get this on my skin. It could cause harm. But also we'd see, well, this chemical here, that's neutral. Now, on your skin, it's probably not going to harm you. Still wouldn't drink it. Doesn't mean it's not poisonous. And similarly here, we've got a very weak acid here. This one going on your skin, probably not going to harm you.